Welcome back to All This Math. This is Professor Parker, and we're going to do a word problem today. This is some elementary math dealing with operations, all right? The actual word problem is typed in the description below the video. Make sure you subscribe to the channel. Make sure you turn on post notifications so you'll be notified when new content comes out. All right, so let me read the problem. Let me first read the problem. The problem reads like this. Mr. Sharp wants to make 3 quilts. Now let me stop right there because everybody may not know what a quilt was, because once upon a time I didn't know what a quilt was. A quilt is like a blanket, like a comforter, like a thick blanket that has designs on it, right? It has designs in a certain pattern. And you can make a quilt that represents different themes, different ideas. You could put historical figures on a quilt. Like you could put a quilt with like people like Dr. Martin Luther King Jr., civil rights activists, human rights activists, actually, more than a civil rights activist. Born January 15th, 1929, 4 years after Malcolm X was born. Assassinated April 4th, 1968, unfortunately, right? But you can make a quilt with a lot of African-American freedom fighters. You can make a quilt with African freedom fighters, Pan-African nationalist strugglers, and whatnot. But anyway, a quilt is a blanket with designs on it, basically. All right, because and that's important to understand, because when we're reading word problems, in order for us to best understand the word problem, we need to understand the vocabulary in the word problem. So understand what we're talking about. Then the problem says Mr. Sharp, he needs 9 cloth squares to make each quilt. So I'm thinking that the quilt is going to look like this. Imagine this is like the quilt, right? And he needs 9 cloth squares, right? So I'm assuming that it's going to be the same setup like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 3 plus 3 is 6. 6 plus 3 is 9. So one of the quilts is going to look like this. All right? The question is, how many cloth squares will he need to buy? So this is a cloth square. That's 1 cloth square. And that's 1 quilt. But Mr. Sharp needs to make 3 quilts. Then the question says, and you'll see this, as I said, you'll see this typed in the description below. Tell which operations and equations you will use to solve the problem. And these are the choices. Choice A is multiplication, which says 3 times 9 equals 27. Choice B is subtraction, which says 9 minus 3 equals 6. So let's talk about this. Now, the question is, how many cloth squares will Mr. Sharp need to buy? Right? Let me get out the way so you can see everything you need to see, right? This is 1 quilt. 1 quilt has 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you draw another quilt, there will be 9 more squares. And you draw a third quilt and the final quilt, there will be 9 more squares. So ask yourself, how many squares is that altogether? 9 plus another 9 plus another 9. So one way to find the answer would be 9 plus 9 plus 9. And what is 9 plus 9? 18. What's 18 plus 9? 27. So 27 is the answer. That's how many cloth squares he'll need to buy. He needs 27 of them, because he needs 9 for the first quilt, 9 for the second quilt, and 9 for the third quilt. 9 plus 9 plus 9. But neither of these options says addition, because we just did addition here, right? Our options are multiplication and subtraction. Now, if you know a little bit about multiplication, you know that multiplication is actually a shortcut. Multiplication is a gift, because multiplication is a shortcut for addition. So instead of doing 9 plus 9 plus 9, ask yourself, how many 9s are right here? 1, 2, 3. It's 3 9s. So that means we basically did 9 3 times. And instead of saying 9 3 times, we could change the order around and say 9 times 3. And 9 times 3 is the same thing as 9 times 3. Now you look up here, you see multiplication, but it says 3 times 9. There's a rule or a property called the commutative property, which says this, and you should memorize this. The commutative property says that when you're doing multiplication, and it also applies to addition as well, but when you're doing multiplication, the order of the numbers does not change the result or the product. So that means I could do 9 times, if I know that 9 times 3 is 27, I also know that 3 times 9 is 27. So just because, so if you get 9 times 3, but this says 3 times 9, just know that this, and this are equivalent because they give you the same product. So the answer is this. Choice A, multiplication, 3 times 9 equals 27. Now, since we got time, and this isn't like a time test or anything, I do want to talk about wrong answers. One of the things I like to do on this channel is not only show what the correct answer is, but also talk about the wrong answer and talk about why it's a wrong answer. So you'll be able to recognize wrong answers when you see them. Because it's also very important not only to understand the correct answer, but understand why it's correct, but also understand why the wrong answer is wrong. Because that helps with our understanding. It helps with our thought process. Now, why is B wrong? B is wrong because it's talking about subtraction. Now, this is what happens, right? A lot of times when there's classwork in school, when there's tests, whether it be a teacher-made test or whether it be a standardized test, if a student doesn't understand the concept of what's happening in the problem, what they do is they'll just look at the numbers and they'll say, oh, well, in the problem, Mr. Sharp wants to make 3 quilts. So I know the number 3 is in this problem. And also he needs 9 cloth squares. So I know the number 9 is in this problem. But if a student really doesn't have strong reading comprehension, but they recognize numbers, then they might just say, oh, well, the problem's talking about the number 3 and 9, so maybe this is right. But if you're doing subtraction, you got to understand concepts. How is 9 minus 3 going to tell you how many cloth squares he needs altogether? You got to think about this in the context of if this was a situation that you were responsible for. Imagine if you were Mr. Sharp, right? If you were Mr. Sharp and you was trying to make these quilts and you know that you need 9 squares for 1 quilt, but you try to make 3 quilts. So you're doing 9 on one of them, and then you need 9 for another one, and 9 for a third one. So at least understand that that's at least 9 plus 9 plus 9. And then understand the connection like we did between addition, repeated addition, and multiplication. But and understand that this can't be subtraction because think about it. At the end of the day, if you do subtraction using this expression, you end up with 6. So just ask yourself, like, because math should always make sense. When you're doing math, your answer should always make sense. If it don't make sense, then it's probably wrong, right? Now, it could not make sense to you because you just don't understand it yet, and it could be correct. But ask yourself this. How can Mr. Sharp make 3 whole quilts with only 6 cloth squares? How would that work? 6 squares? How is 6 squares going to be enough? If it take 9 squares just to make 1. If it take 9 squares just to make 1 quilt, and he want to make a whole 3 of them, how would 6 be enough to make all 3 when 6 ain't even enough to make 1 of them? These are the questions you got to ask yourself when you're doing math homework and when you're doing these types of questions. And also understand why, like I said, understand why answers are wrong. Because once you understand why answers are wrong, then you'll feel more confident in your correct answer. You'll feel more confident saying, oh yeah, it's got to be multiplication because he wants to make 3 quilts, so pay 3Q, and 9 squares on each quilt. So that's 3 quilts with 9 squares on each one. 3 times 9 is 27. And we broke that down right here, right? So this is one of the ways that I think you should approach word problems. Read the word problem, understand the word problem, think about what the word problem is asking you to do. Look at think about the scenario. Just imagine, put yourself into the equation, put yourself into the situation. Imagine this was you trying to do this thing, right? And then it'll start to make more sense. And also look at your wrong answers too and try to prove why the answer is wrong. Like we said, how he gonna make 3 whole quilts with only 6 squares? How you gonna do that? It's not possible. He can't do that. He can't do that. It's not enough because 6 is just 1, 2, 3, 4, 5, 6. He can't even make a whole 1 quilt with 6 squares. He can make 2/3 of a quilt or 67% of a quilt. I don't know, I'm throwing like fractions and percentages out there at you. I got other videos that go into fractions and percentages as well, all right, that I suggest you take a look at also. But just think about it. Just think about it. Understand the concept and just try to pick the answer that makes sense and also understand which answer doesn't make sense. All right. So this is a good example of a word problem that tests our ability to understand the connection between addition and multiplication and also why subtraction won't work in a certain scenario. And it also tests us on our ability to translate a word problem from a word problem into a mathematical expression. But I highly recommend you go practice some more problems like these. So ask your teacher or whoever for more examples or go online and do some research to find some examples like this. You can sharpen your skills and do more and more word problems, because word problems is where it's at. If you can do word problems, then you'll be good, because it's all about problem solving. And problem solving is a life skill. All right? I'll see you in the next video. Peace.